Hi and hello everyone. Today in this video, we are going to present our project on predict and interpret the presence of COVID-19 in radiographical images. This presentation is part of our course CS842 Introduction to Data Science. Let's get started. In this presentation, we are going to talk about each of the data science lifecycle process which we followed while building the project. Let's talk about the first data science lifecycle methodology, that is discovery. Coronavirus disease, which is also called as COVID-19, is an influenza disease caused by a newly discovered virus called as SARS-CoV and -2. This was started in the month of December and it's still going on, and it has affected a lot of people. Government of different countries have imposed a lockdown, but due to which it has impacted the economy of that country in a very negative way. Even though governments have made mandatory laws to follow social distancing and increase the awareness in the hygiene, but still the virus is spreading rapidly. This virus has caused old age people to with severe illness such as pneumonia or diabetes to lose their life because they are more in risk. To tackle the COVID-19 virus, the one thing is to do is invent and develop a vaccine. But vaccine has to go through a lot of clinical trials and get approved, which can take a lot of time. So existing methodologies such as RT-PCR is can detect COVID-19, but it is not effective because it is a manual process and it is expensive, and also the false positive rate is quite high. So the testing is very important when it comes to control the virus, as without the tests we can never know who is infected and who is not, and the person who got infected can spread the virus to other persons and it may spread to everyone and cost lots of lives. It turns out X-ray images of COVID-19 patients have similar pattern in the chest X-ray images, such as ground glass opacities and the crystals in certain area of the images. This can be used to detect the presence of COVID-19 virus in a person using machine learning models. But wait, is this trustworthy? No, how people are going to evaluate is what the model is showing them, is it right or not? So here is where the interpretable machine learning models comes into.
Coming to the related works, medical field is a major consumer in adopting the convolutional neural networks with their image data analysis tasks. Convolutional neural networks play a major role in the recent advancements of deep learning field for image analysis tasks, extending the capabilities of a convolutional neural network models from being a black box container to an interpretable white box tools is a major advancements toward explainable artificial intelligence. Object detection and localization task in the convolutional neural networks has been major milestone in this field. The advent of proto-unit approach for the image detection and localization tasks turns out to be a game changer, where the model explains which parts of the image contribute to the model classification.
Size of the data set The size of this data set is around 1.2 GB. It consists mainly of X-ray images of viral pneumonia or positive COVID-19 patients and even normal patients. Uh, so we had the and all of them are in .jpg format, and so it contains around 219 X-rays of positive COVID-19, and 1341 images of normal people X-ray images, and also 1345 images of viral pneumonia. And this data was extracted maximum from the articles. In this slide, we are going to talk about the chest X-ray projections. The projection, projection means the view of the chest X-ray that has been taken by a radiologist. There are different types of projections, but here we are going to talk about the four major chest X-ray projections only. The first one, which is the most common projection, is called posterior anterior projection. This, this is acquired by making the person stand up and by passing X-ray in from the posterior to the anterior of the person's chest. The second one is the anterior posterior projection. Here, it is an alternative method used for patients who are not able to stand properly. Here, the projection will happen from anterior to the posterior. The third one is lateral projection. A person needs to stand in the side way, and the X-ray will be passed through the lateral side of your body. And the fourth one is axial. This type of projection is used when to analyze the lung areas. However, the image is not cannot be seen clearly because of the underlying tissue. So in this type of scenario, we use axial projection. In this data set, we can see there are different types of chest X-ray images, such as shown in the first table, such as like COVID-19, pneumocystis, streptococcus, COVID-19, normal, and SARS. Here we find one thing interesting. That is, the number of images of COVID-19 is around 180, and for others, it's really less. So it can cause it can cause high biased. It can cause model to predict high biasly. To overcome this solution, we have to balance the data. So we are going to take only 15% of COVID-19 images into training data set, which we are going to talk about in the next slide. So in order to train our model, we are going to split the original data set into two different data sets. One called training and another one is testing. The training will be composed of 80% of the original data set, and the testing will be composed of 20% of the data set. Here one thing we are doing differently is we are going to take the 85% of the COVID-19 images and put into testing, which we disregarded in the previous process because of the unbalanced data set. And the second thing we are doing is we are resizing all the images to 224 by 224. And also the third thing is we are changing all the images from color to black and white such that the pixel values will be 0 and 1 only.
The given dataset contains a labeled set of images. After all the pre-processing steps followed in the previous phase, there is a need to build a model for predicting the user input image as COVID-19 positive or COVID-19 negative. This is similar to the churn rate prediction problem. The problem is to identify the class of object that is image uploaded by the user to which it belongs to and interpret the region in the image for respective classification. As the input image is to be classified among the classes COVID-19 positive or COVID-19 negative, the model can be identified as classification among the category of techniques used to solve the problem. The labels are already provided for the data to train the model, making it a supervised learning when training the classification model from dataset. The given dataset can be formally described in this following language, where xi is the feature vector of the image, we having a 3 into 3 times 24 224 times 224 dimensions, and yi represents the actual label of the image xi. The given input for the model is input image data. Convolutional neural networks are one of the leading classification algorithms used for classifying images among the respective classes. Convolutional neural networks are employed to build a classification network of the images. The core components of convolutional neural network involves a certain iteration of convolutional layer and a pooling layer, usually with different parameters in every iteration, and a flattened layer at the end of those iterations to process the resultant features of the image into a fully connected dense neural network represented as a multi-layered perceptron. The final layer in the convolutional neural network is the output layer that classifies the image among the respective labels. Convolution layer helps in applying the filter to the image. For example, a 3 by 3 matrix of certain parameters is applied to the overall input image to bring out the vertical image in the X-ray image. The resultant image is then injected into the pooling layer to bring out the compressed format of the filtered image by reducing the dimensions. For example, max pooling 2D is employed to compress the filtered image to get the maximum value of every 2 by 2 matrix values in the image. After a certain number of iterations, the flattened layer transforms the resultant image dimensions into a single vector as an input to the dense neural network. Recognizing the decision class that is COVID-19 positive or COVID-19 negative is considered as an object detection task. This is achieved by taking the dataset and imposing the convolutional neural network architecture over the dataset and train the model as shown in the below figure. The final output of the convolutional neural network architecture are the image classes, that is COVID-19 positive or COVID-19 negative, and the respective accuracy of classifying an image to respective class. The class corresponding to the top accuracy is preferred for the model decision. Uh, the deep learning models, especially the convolutional neural network models, needs a high computational cost to train the models. The concept of transfer learning helps reduce this effect by enabling the users to customize the pre-built models, which helps in reducing the training time and faster convergence. The pre-built models like DenseNet 121, as shown in a figure, are a good starting point to initialize the network parameters rather than explicitly training the model with random parameter initializers. Convolutional neural networks suffer with a gradient vanishing problem when working with more layers. DenseNet helps reduce this problem by concatenating the every previous layer to the future layers. This is helpful to process the maximum information flow in the feed-forward network and maximum gradient flow during the back propagation in the network. This type of feature reuse technique can help in reducing the number of parameters to learn in a network, and in turn reduces the number of redundant feature maps generation. Here, the dense blocks helps in concatenating the feature maps of previous layer to the next layers of the network. The transition blocks helps in compressing the feature maps with 1 by 1 convolution filters and 2 by 2 pooling, making all the feature maps in dense blocks half in volume and size. Now, retraining the parameters of final convolution layer and the dense network of multi-layered perceptron in the architecture with the X-ray images results in faster training and convergence of the model. The optimizer used in the model is Adam with the learning rate of 0.0007 and weight decay factor of 10 power minus 6 with the network for the network parameters. The loss function used in this project is BC with logits loss, that is binary cross entropy with logits loss. AU score is used as the metric to test the model as this metric plays a major role in medical field. The interpretation of image classification task in convolutional neural networks is one of the major branches in explainable artificial intelligence. There isn't any spatial location information of the image when an image is flattened and processed in a dense neural network. The spatial location of the image is maintained till the last convolution layer of the network. The class activation maps obtained from the final convolution layers in the CNN architectures are the main contributors of the decision classification in the network. An activation score is obtained by the gradient flow backpropagated for every perturbation in the activation maps of the layer during the training. Interpreting the model classification is done by observing how good every activation map contributes to the final classification of the model. Hence, the input image regions corresponding to the receptor fields in the activation maps helps in interpreting the region of interest for the final classification. Using the proto-peanut architecture, a weight is associated with every feature map in the last convolutional layer with respect to every class of the classification. These weights are the averages of the gradients of every pixel of the activation map with respect to every label. When a user uploads an input image, the image is processed through the model, and when the final convolutional layer is reached, the processed image is applied to 512 kernels, upon which receptor fields in the image with respect to the kernel is highlighted. All the 1024 activation maps, that is 512 activation maps concatenated from the previous layers and 512 activation maps generated in the current layer, are multiplied with their weights with respect to the class labels of the model, followed by averaging them to form a final heat map of the receptor fields of the input image with respect to class label. Uh, there will be 6 activation maps produced for each of the 6 labels. These activation maps are upscaled to the size of the original image and imposed onto it to highlight the region of interest with respect to that classification label. If the activation score is achieved for COVID-19 class label, then the classification of image can be set as COVID-19 positive. If the classification score is achieved for any other class other than COVID-19 class label, then the classification of image can be set as COVID-19 negative. We used a convolutional neural network based transfer learning methodology to develop a model for detecting COVID-19 positive or negative status. We have integrated the model with the website where the user can enter their name and upload their chest X-ray images. After that, they can click a submit button for which we will run the COVID-19 detection model and gives the output with a gradient color coded image as well as the result of COVID-19 status as shown in below figure. The gradient color coded image which is generated by the model represent the important areas because of which the result is classified as positive or negative. For instance, the below image output result is COVID-19 negative. Now, a doctor or physician can see the output image and see that the machine learning model has considered the area which are shaded in purple color and can contrast with the original image and confirm the status. AUROC score has a high priority in medical field as it deals with the area of the graph attained for true positive and false positive rates. An AUROC score of 0.9 is considered as a decent level of model score. Our model has achieved an average AUROC score of 0.944, and for the COVID-19 images, it has attained a score of 0.963, as shown in below figure. As the model has been trained using the smaller dataset, this model should be tested with larger dataset, and the model has to be trained with image augmentation such as image which is tilted at 16 degrees like that, etc. Moreover, currently the model is binary classification model, which means it only predicts COVID-19 status positive or not. In future, the model needs to be multi-class classification where it can automatically detect pneumonia, SARS, and other similar diseases, etc.
The technical requirements for the project, from analyzing and exploring the data to building our web application, we have used some of the excellent open source and programming languages. First, Python. Python is a programming language. We all know that it's open source. and we have a lot of inbuilt packages and libraries to explore the data to implement the machine learning algorithm in a easy way. And some of the machine learning algorithm what models we have used are skitlearn for building the models, and PyTorch for building the CNN models and analyzing the images. And we have used the Jupyter Notebook and Google Colab as our online editor for building the application. And for building the website, we have used HTML and JavaScript and CSS for our front-end design and user interface, and Django as a server language, which passes the request from user interface to the backend machine learning. And database we have used PostgreSQL, and we were supposed to deploy our application to the hierarchy cloud, but due to time and space constraint, we didn't deploy our application to the cloud. But we have given all the details of our application and how to run the application in your local in the application setup guide. Please go to the guide and let us know if you have any other questions regarding the installation. Then coming to operational, as I already said, we are supposed to deploy our application to the cloud, but unfortunately we didn't deploy our application to the cloud. But we have shared all the technical document and code link to the professor. Please do review the code and the links. And regarding the website, it's a very simple website which contains only 3 to 4 pages. First is homepage, then a result page, and one is about the patients, and and another page about the teammates. Basically, in the teammates, we'll just see our pictures and our details. And the home screen contains of one button, one upload, one file upload button, one input field where you have to give patient's name and upload patient's CT scan image and submit the image for the analysis. And once you submit that image, our machine learning model will analyze the image and classify the image as COVID positive or negative and give the feedback in the next screen. So there are a lot of scope for development in our project. Like as I already said, we built a very simple website. So if you have want to enhance the user experience and introduce new features in our application, definitely there's a lot of scope in our application. This is the architecture of our application. You can also call it as a high-level functional diagram. If you could see, there is a user, there's a website, there's a database, and there's a model. And here user can come and input his image and name to our website. And website is basically called our machine learning model, and um, it outputs two values. One is highlighted image and COVID-19 result. And also the website will connect with the database to retrieve the image and save the images. Thank you for watching the video. Please let us know for any questions or suggestions on our project work. Thank you.